global versus local theories. Even within cognitive neuroscience, there are many different theories of consciousness. It is useful to roughly divide them into two camps. One camp is what we can call global theories. According to these theories, consciousness requires many areas of the brain working together. Let's say we are talking about consciousness in vision. That is, what distinguishes between consciously seeing something versus just having visual information unconsciously registered in the brain. According to global theories, for a stimulus to be consciously seen, it would require more than just activity in the visual areas. The stimulus needs to be represented more globally throughout the brain. One representative theory in this camp is the global neuronal workspace theory, championed by various people, including Stanislas Dehaene. The theory is inspired by an older theory from cognitive psychology called the global workspace theory, proposed by Bernard Baars in the late 1980s. So the idea is that, as we have studied so far in this course, there seem to be functionally specific modules in the brain, like modules for visual perception, motor control, language, long-term memory, etc. They are called modules following the idea of the philosopher Jerry Fodor, who described these modules as informationally encapsulated, meaning that the workings within a module are somewhat private. Let's say for motor control, it takes an input, which may be a command that the hand needs to reach out. From there, it needs to work out how the different muscles need to be activated, which involves very complicated computations. All of this is opaque to the other modules. The motor control module sends out signals to the muscles without telling everyone else how it does its calculations. Likewise, other modules can influence the input to the motor module. But how the motor module does its own thing is not something that other modules can influence, nor should they care. So, assuming that the mind does work in this modular fashion, how do the different modules communicate? For certain modules, there may be specific dedicated pathways. For example, from vision to motor control, there may be specific pathways through the dorsal visual stream for online control of fast reactive actions. But what about some general purpose communication between any two modules, or a conference call between multiple modules? It is suggested that there we have a global broadcast mechanism called the global workspace, a bit like a central control system, an information marketplace which every module has access to. Information represented there can be edited by every module and will be seen by every module. So, according to global theories, consciousness happens when the relevant information enters this global workspace. If the representation for a stimulus fails to enter this workspace, we won't be conscious of the stimulus. According to the global neuronal workspace theory, workspace representations are supported by activity in the lateral prefrontal and parietal cortices. Now then, contrast this with the local theories of consciousness. Take vision as an example again. For local theories, all it takes for a stimulus to be consciously perceived is for it to trigger the right kind of activity patterns within the visual areas. One representative example of a local theory is Victor Lama's local recurrency theory. According to the theory, the right kind of activity needed for conscious visual perception to happen is feedback from extrastriate areas back to V1. So feed-forward activity from V1 to MT may represent unconscious motion signals. It only becomes consciously perceived when there is also feedback activity from MT back to V1. Like the global camp, there are different versions of local theories too. For instance, in Rafi Malik's view, it is local activity within extrastriate areas, rather than feedback to V1, that may be critical for conscious perception. But all the same, the common main point of all local theories is that the activity in frontal and parietal cortices is not absolutely needed for conscious perception to occur. Dividing theories like this into two broad camps is definitely an oversimplification, but it helps us to see the lay of the land. As we will see in the next section, there are central issues that set these two camps apart very clearly. Once we see how these two camps serve as polar opposites on these issues, we can see the whole range of possible theories within a reasonable spectrum.